Welcome and study with Tanzania Institute of Education.
Sodium carbonate solution is usually prepared as a primary standard base. This alkali can be used to standardize various acids. The aim of this experiment is to prepare 0.142 molar standard solution of sodium carbonate. Requirements: apparatus, glass rod, filter funnel, a beaker, watch glass, measuring flask, chemicals, distilled water, and anhydrous sodium carbonate. The equipment: beam balance. Procedure: using a beam balance together with watch glass and a spatula, measure 3.75 grams of anhydrous sodium carbonate. By using a beam balance, you take the anhydrous sodium carbonate to the watch glass, then adjust the beam to the 3.75 grams of anhydrous sodium carbonate. Take the watch glass with the anhydrous sodium carbonate. Take a beaker. Put the anhydrous sodium carbonate in the beaker. By using a wash bottle filled with distilled water, rinse the watch glass so that all the particles enter in the beaker. Thereafter, using a glass rod, stir the mixture so that all the particles dissolve, while adding water from the wash bottle. Take 250 ml measuring flask, open it, then by using a filter funnel, pour the solution of sodium carbonate to the measuring flask. Then rinse by using a wash bottle the beaker so that all the particles left are taken to the measuring flask. Also, rinse the glass rod to obtain all the particles. Add some more water so that to reach the mark of the 250 ml. But remember that when you're approaching the mark, to use a wash bottle so as not to exceed the required amount. Use a wash bottle, carefully observing the meniscus. Remove all the air bubbles. Now you have the solution ready to the mark. Shake the solution well so that the solution is uniformly mixed. To understand the concentration of the solution that is prepared, use the shown calculations. Find the relative molecular mass of sodium carbonate by taking the sum of atomic mass of each atom which make sodium carbonate. The sum comes to 106 grams per mole. Therefore, this is the relative molecular mass of sodium carbonate. The concentration of sodium carbonate in grams per decimeter cube can be calculated by taking the grams that we have weighed 3.75 grams dissolved in 250 ml of distilled water. Therefore, in 1,000, we calculate the amount of grams that were present. Through calculations, we obtain that we have 15 grams of sodium carbonate in 1 liter or in decimeter cube. Thereafter, find the molar concentration of sodium carbonate by the formula molarity equals to concentration in grams per decimeter cube over relative molar mass in grams per mole. Substituting the grams, the concentration in grams per decimeter cube and relative molecular mass of sodium carbonate, you have molarity of sodium carbonate is 0.142 moles per liter or per decimeter cube. The solution prepared has the molarity of 0.142 moles per decimeter cubed. Label the flask showing the concentration of the solution. In this experiment, a primary standard solution of sodium carbonate has been prepared.